Hi everyone, we are Group 11 and our project is Deduplicator. For our project description, Deduplicator is implementing efficient algorithms to store similar files in Locker with low storage. We design a compressor to store files and a decompressor to retrieve files. For example, if you want to store 10 MB files in our Locker, it will only occupy at most 100 MB of storage. For our features, our basic features is you can store similar files and you can retrieve files from our Locker. And our Locker is always portable. It means that you can use a USB to copy our Locker. And you can communicate with our deduplicator using the command line. We also implement 7 possible features. You can delete files, search substring, and store similar images. You can also store directories of files as one entity. We can support access from network, GUI, and Android client. As we mentioned before, we use a compressor to store our files. So the main step of our compressor is to split a file into many parts and compare each part with the reference file separately. We regard the first file stored in the Locker as a reference file. For each slice, we are going to store as 2 files. One is a different part of the text, which we call different char file later, and the other one is the index file. For the algorithm part, firstly, we compare the slice of reference and input file using MD5 hash value. If the values are the same, then we go to the store step. If the values are different, then we divide the slice into 2 parts. For each part, it will be handled by Sunday algorithm. After that, if the string of input file is contained in the reference file, we are going to the store step. If they are not matched, we will use dynamic programming to find the longest common substring of the common part. The common part will be sent to the store step and the remaining different part will be stored in the different char file. The store step is to store 3 data in the .common file. The detail will be introduced in the example. Here is a small example of the compressor data structure we just mentioned in the store step. On the left side, here is the reference file, and on the right side, we store 2 files generated by input file. The first one is the index file. In the indexed file, the first column is the index of the same substring in the input file. The second column is the index of the same substring in the reference file, and the last column is the length of the same substring. We also stored a file with the different chars in the input file compared with the reference file. And we mentioned 2 algorithms before, so the first one is the Sunday algorithm. Sunday algorithm is used to match substring. It is an implement of the BM algorithm. The amortized time is ON. We can show you a small example. If we want to find the pattern string, the word search in the main string substring searching, first, we assume the length of word search is m. In the first step, we find char u and e is not matching, so we compare the I in the position of m plus 1. If the char I doesn't appear in the word search, we shift m plus 1 position. In the second step, we find char R in the word search, so we shift m minus the rightmost position of I. In this example, the shift is equals to m minus 3. Finally, we got a string match. But if we cannot get the string match from the Sunday algorithm, we need to use the dynamic programming to find the longest common substring. The main idea of the dynamic programming is we just store the same subproblem once, so the amortized time is OM times n. We just need to find the largest number in the metric after building the dynamic table, so we can find the longest common substring. For the basic feature, we need to retrieve the data, so we design a decompressor to restore the original file. Here is a diagram of the decompressor, but we want to use an example to explain this. And you can see 3 files on the right side, the reference file, the index file, and the different charts file. And first we need to read the first line in the index file. And we get the second and the third number. And the first one we need to point to the index 0 in the reference file and get a string of length 4, which is 1, 2, 3, 4 in the reference file. And we need to put it at the index 0 in the different chart file. So the file will change to 1, 2, 3, 4, blah, 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 as below. And then we need to read the second line. The same as the first line, we need to point to the index 9 in the reference file and get a string of length 6, which is AHOEIU. And we need to add it at the index 10 in the different charts file. So the file will change to as below. And after we read all the lines, we will get our result. The file is shown as this one. And after the basic features, we also want to introduce some ideas of our possible features. For the substring search, we try to find the longest common substring of the reference file and the input substring. And we want to extend the index range. This might be a little confusion. Let's do an example. In the reference file, if the index of the longest common string is 100 and 1000 and 1500, we will the substring length is 500, we will extend the substring index to 500 to 2000. And we will use the index file, the new substring, and the different chart file to use the decompress, and we will get the result. If the substring is in the decompressed file, the result is yes, and if in the opposite side, the result is none. And for the deletion, we just use the input file name to search the file which contains the name and delete them. And our feature innovation, we create an Android client. For the Android client, it combines several Java code from the Deduplicator project. If we push the bottom, load and compress, then the virtual machine will load files from a folder in the AS project folder. If the files are originally stored in the SD card, then the users can tap the name to load. After tap that button, the compressed file will be stored in the SD card, which is set as locker this time. The file contents are also displayed on screen with the file content after compressed. For the next step, we can tap the name of the decompress. You can find the result here on the screen. And well, for the deletion function, there is no difference between that and the file used in the command line. And here are some of our reference for our project. And next, we will demo our program.
This is the demo for our project. First, we open the server side, and then we open the client on the other computer. And then we enter the host address. Then enter the port address. And here's our GUI. First, we demo the upload file part. Now we enter the locker name as group11 and choose a file to upload. And press upload. At the server side, we can see that the locker is created, and we also send back a storage status back to the client. And we upload another file. And we can see that the locker usage is a little bit larger than the first one, so it is compressed success. Now we've already uploaded 5 text files, and you can see that our locker usage is only 10.4 megabytes. And now we demo our retrieve part. We enter name task 3 to retrieve. Press retrieve. And now the original file is sent back to the client on the desktop. Here's the original file that we retrieved. Now we demo our deletion part. We enter task 4 to delete. Press delete. And in the locker you can see that there's no task 4 and the locker usage is sent back to the client. Now we demo our search part. We enter the sentence we want to search in the locker. Now we can see that the sentences exist in these 4 files. This is our demo for saving directories of files as one entity. We use our command line to do this demo. Here's our test folders. And we also have a subfolder under this folder. It contains 2 text files. Now we upload it as one entity. And we create a locker on the desktop. Now we can see that the locker is created on the desktop and it contains all the files in the test file.